Assalamualaikum and very good morning. First of all, I would like to thank all participants for joining this webinar with the title of Development of Grid-Connected Photovoltaic System in Malaysia. This webinar is broadcasted live on I3P Malaysia YouTube channel and Facebook platform. This webinar is organized by I3P Malaysian Student Branch and co-organized by I3P Power and Energy Society, South Malaysia. I am Anis Nazira from I3P University Technology Mara, YGM Student Branch, and I will be the MC for this session. Our speaker today is Honorary Professor Dr. Ahmad Maliki Omar, lecturer at School of Electrical Engineering, formerly known as Faculty of Electrical Engineering, University Technology Mara, YGM Shah Alam. He will be giving a talk on development of grid-connected photovoltaic systems in Malaysia. Before I pass the session to our speaker, I would like to inform you that if you have any questions regarding the discussed topic, you can type your question in the YouTube and Facebook chat box. I will post the questions to the speaker during the Q&A session. First of all, I would like to invite Associate Professor IR Dr. Ahmad Farid Abidin, Commit Member for I3P South Malaysia, to give a brief introduction to I3P South to all of you. Dr. Farid, please.
Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning. Thank you, Mrs. Anis as a moderator for the sessions. And please allow me for a few minutes to introduce what is I3PE PES. So I3PE Power Energy Society, who we are and where we are going. So looking to the I3PE strategic plans 2020 to 2025, the mission of I3PE is we foster technological innovations and excellence for the benefit of humanity. And the vision of I3PE as such that we will be essential to the global technical community and to technical professionals everywhere, and be university recognized for the contribution of technology and of technical professional in improving global conditions. And we have encompassed the core values, which is based on trust, global community building, integrity in actions, service to humanity, partnership, and growth nurturing. And as an association, the I3PE will drive global innovation through broad collaboration and the sharing of knowledge, and enhance public understanding of engineering and technology, and pursue standard for their practical applications, and be a trusted source of educational services and resources to support lifelong learning. And we also provide the opportunities for career and professional development. And we will inspire a worldwide audience by building communities that advance technical interests, inform public policy, and expand knowledge for the benefit of humanity. I3PE is the world's largest professional association advancing technology for humanity, where we have a global reach about more than 400,000 members across to 160 plus, more than 160 countries. And along the way, we have 123,000 student members, and almost 2,000 annual conferences have been organized under I3PE. In terms of technical breadth, we provide more than 4.5 million technical documents, more than 200 top-cited protocols, and more than 1,300 active standards. And also we have the 49 technical societies. And in terms of social impact under I3PE, I3PE had engagement with the public policy, and we make an effort in terms of global humanitarians, in terms of education and certification. Also, we conduct certain activities, and also we do have the ethics in technology. And in terms of PES, let's resume to the PES. Okay, PES is the second largest technical society in the I3PE. Okay, we have 37 other technical society plus PES 38. So PES is the second largest, which is organized or been under I3PA. So looking to the standards which have been developed or established under I3PA, there is a 45% standards under I3PA are created or established by PES. So I3PA Power and Energy Society membership can help you. Okay, how we can help you when you join us as a membership. Okay, for the member, we can grow and maintain your technical expertise and get connected to other professionals, contribute to the future of power and energy, and save money for the valuable program and materials. As we know that I3PA provide so a few technical program and also the accessible to the technical material in terms of standards, in terms of journal, in terms of proceedings. Okay, we do have a few activities. Okay, looking to this the current or the existing and the previous activity, we conduct the online and webinar tutorials. Also, we conduct the on-site training and workshop, practice-oriented technical journal, and plain talk for the basic courses for industry novice. And as a PES, we deploy a significant resources for training and lifelong learning activities for our practicing engineers members. Okay, many resources are eligible. Okay, under PES. For the I3P PES Resource Center, okay, it can access over 1,400 items, which is the most extensive library of content in the world devoted exclusively in the field of the power and energy. So all together have been placed in one platform. Okay, we can have access to the tutorials, videos, technical reports, journal articles, archive webinars, conference slides, and many more materials that have been can be accessed through this platform. Okay, looking to the global engagement through the local chapters. Okay, we have 10 regions. Malaysia have been located at the region 10, where we have 45 chapters with the members of 9,375 members. Okay, here the leadership PES, which is started on 1994. Okay, currently our chair have been led by the Prof. Hazli. Okay, what we did, okay, the activity that have been organized or have been conducted under PES, especially PES Malaysia. Okay, we do have invited lecturers, conferences, and we do give the awards for the outstanding engineer and linking with industry. This is also the important part when we been under PES. There is a accessible or a close collaborative effort with industry. We do have a technical activities, final year project awards, reaching out to members and senior member drive. Okay, if you are not a member of PES yet, so please join us. Okay, you may become one today. Okay, there is a special privilege for the students. Okay, where we provide the free PES student membership for 1 year only. Okay, so a few listed privilege that can be obtained when you join a PES student membership, where you're able to enjoy a free subscription to the PES award-winning Power and Energy magazines, gain free access to the PES Resource Center with hundreds of technical reports, tutorials, videos, and presentations. And the member also receive free membership in your local PES chapters and receive discounts at dozens of PES sponsored or co-sponsored conferences and meetings in your area and around the world. And there is a discount in terms of technical tutorials. And also there is a PES Careers, which is a free service designed to specifically help undergrad and graduate engineering students connect with employers in the power and energy industries. Okay. But the offer is only valid for the individual for only 1 year. Okay, and also those who are or who have never been in a PES member before. Okay, join me as we bring more power to futures. Okay, there is a PES email over there, and please visit our website and as well our Facebook that's been put in the slides. Okay, this is our ESCOM. Okay. Okay, thank you.
Introduction to I2PA. We hope that those who have yet to register as I2PA member will join us as we will get all the benefits mentioned by Dr. Farid just now. Now, it's time for the main agenda. Let me introduce our speaker for today, Honorary Professor Dr. Ahmad Maliki Omar. Currently is an honorary professor at the School of Electrical Engineering, formerly known as the Faculty of Electrical Engineering, University Teknologi Mara, Shah Alam, Selangor, Malaysia. He is active in teaching, training, consultancy, and research in solar photovoltaic, PV power systems, power electronics, and dedicated controllers. He has been the Malaysian representative at IEA PDPS 11. He is also the master trainer and examiner for the Sustainable Energy Development Authority (SEDA) competency program. Deputy Chairman of the PV Working Group for MS Development. With the introduction just now, I would like to call Honorary Professor Dr. Ahmad Maliki Omar to share his expertise on development of grid-connected photovoltaic systems in Malaysia. Prof. Maliki, to you.
Okay, thank you very much, Ms. Anis, for the introduction. Assalamualaikum, very good morning, very good afternoon, very good evening to wherever you are. Uh, the title of my talk this morning is about development of grid-connected photovoltaic system in Malaysia. So the talk actually based on my experience involved in this grid connected PV system since the beginning of starting of grid connected system in Malaysia. So my name is Ahmad Maliki bin Omar. So the content of my talk this morning is going to be the introduction, overall introduction about photovoltaic system for those who are very new in this area. Probably just give you the overall pictures about what is photovoltaics. I'm not going to go detail into the physics or how it operates, but to give you a general picture about the photovoltaic power system that we use in Malaysia. I'm going to talk about the historical development of GCPV system in Malaysia. So starting way back in 2005, the beginning, and until now. And I'm going to talk about how does this GCPV system works. So many of us maybe this is a new and you have no idea how this PV system works. Yeah. And what are the types of GCPV systems has been implemented in Malaysia context? And I also will mention about what are the standards, related standards. We have developed our own indigenous Malaysian standard related with the GCPV system. And beside that, we also rely on the international standards such as IEC standards, I2PA standards, Australian standards, and other countries when we try to compare and try to get benefit of it. And I'm going to show some of the picture of GCPV system installation in Malaysia. And lastly, I will conclude my talk about this GCPV system. Okay, let me introduce the photovoltaic power system. In Malaysia, there are two types of application as far as PV, I call it PV, short form for photovoltaic. There are two types of application. We call it one is off-grid system, or in short, we call it OGPV, or sometimes people call it a standalone PV system. So another one is grid connected, or in short, we call it a GCPV system, or sometimes people call it the grid tie system. So some literature they refer as a grid tie, some literature they call it a grid connected. It's the same thing, yeah. And for off-grid system, normally there are many circuit topology that you can implement on the off-grid system. Basically, this off-grid system is mainly to design the PV system, whereby you can provide electricity, you can provide electrical power to that particular load. But GCPV system is the other concept where you need to have a grid and you need to transfer whatever power that you generate to the grid, then you can take back. So later on, I will explain these two differences. Now, as far as the OGPV system in Malaysia is concerned, these are the topology that we use to install the system: PV battery, PV hybrid, and direct couple system, and AC couple system. So regarding the PV battery system, this is the simplest topology, simplest circuit that you can implement off-grid system. So off-grid system is mainly to provide power direct to the load. So if you have bulb, you have motor, or you have whatever electrical load, then we can design this PV system to power up or to give electrical power to that particular load or to drive that load. That is the purpose of OGPV system. So the OGPV system usually installed at the remote area where you have no accessible to the grid line. So it's quite far from the grid line. So we install this option, off-grid system. We call it off-grid PV system. So PV battery is as simple, and normally you can find this one on a lamppost, for example, simple 1 or 2 module they provide to light up the bulbs on lamp, the lighting. So for the street lighting, for example. And if you have a bigger system where you need to power up one whole community, maybe consists of 5 households, 50 households, for example, then you need to have a bigger system. So they had developed another topology they call it AC couple system, and this AC couple system is why it used in Sabah, especially on the school power up, to power up the school. So they use this AC couple system. That's advantage of this AC couple system, where you can interconnect between one village to another using this AC couple system easily. Why? Because this dealing with AC, you can easily step up and step down the voltage using a transformer for long communication or long transmission of power. So we can use the AC coupled system. And this system, AC coupled system, the pioneers, that company that developed is SMA Technology. And PV hybrid system is the one that you use this discrete component where you have a genset. And in fact, AC coupled system also you need to have a genset in case, especially in Malaysia, we know that in December we are in monsoon season, so there is not enough sunlight to charge the battery, for example. Then we can use this genset to help us to provide the additional power or as an alternative to the PV system. So that's what we need to have a genset. But usually this system is for the large system. But if you have a small system, we don't have a genset. We just use PV and battery. This is talking about to power up one community, consists of 50 households, for example. So we're talking about quite big power. And also, this is also another topology called PV hybrid system, where they come up with a PV hybrid. They use a PV hybrid inverter, or sometimes they call it all-in-one inverter, where you have all the charge controller, you have a battery charger, you have inverter, they built inside this hybrid inverter. So you do not need to have any discrete component. So you don't have to buy this separate component, charge controller, battery charger, and inverter. They come all together in a small unit they call hybrid inverter. That you can connect your PV array, load, energy storage, and genset. So at present, energy storage, they use a lead acid battery. Of course, nowadays people try to use lithium ion. There are many versions of lithium ion. So that's how people want to replace those lead acid because of maintenance-wise, long duration of operating hours, and so forth. Another type of topology is this direct couple. So this direct couple, you don't have any energy storage, but normally for direct couple, normally we use to power up water pump. So you can have a water pump without energy storage, just use a PV array, and you need a special controller to run the water pump. Now, but the intention of this morning talk is focus on grid connected. I'm not going to go detail of off-grid, maybe later another session, and then we can talk about this off-grid PV system. So what we are going to focus this morning is on grid connected PV system, this topology. So we have this topology, what we call as direct connection or direct connect to the grid. This is called direct connection to the grid. You imagine your house, you consist of this particular electrical wiring connection. You have a cut-off fuse formation. This is a typical arrangement of system. You have cut-off fuse, normally 63 ampere in front of your house, and then you have an import meter, and then you have an AC distribution board, where this consists inside there, consists of circuit breaker and so forth, then connect to your load. This is your present system. And if you want to add up the GCPV system, which consists of PV array, grid inverter, and also we need to put one meter here, we call it export meter, and connect to the grid. This is direct connection, means you bypass everything, connect direct to here. So this is only applicable for feed-in tariff scheme. This one, because it's FIT, where you can sell this electricity to the utility. That's why we need to have an export meter. And import meter, the one that record how much you consume energy from utility. So you need to pay this based on import meter, but utility will pay you based on export meter. This is only applicable for feed-in tariff scheme. I will talk about FIT scheme later. And also, we have another connection, type of connection, we call it indirect connection. Indirect connection means instead of you bypass everything, then you need to connect to the AC distribution board here, AC distribution board. And also, we need to change the meter here. So instead of import meter, the import meter also at incoming here, we record also some export energy to the grid. And in Kelang Valley, I was made to understand that our utility, TMB, is in the process of upgrading the present meters, so they want to replace with the smart meter. So inside the smart meter, there are two types of meter they record. How much you consume energy from the utility will be recorded by the import meter, and how much energy that you send to the utility then will record by the export meter. So at the end of every month, they will minus. So they will offset whatever export meter recorded here, and the balance you will pay. And if there is still some positive balance, for example, it will proceed to the next month. So we roll over for 1 year only, and then after that you reset back. This is how the NEM is implemented, or SelCo scheme we call it. NEM stands for Net Energy Metering. SelCo stands for Self-Consumption Scheme. So this is how it will be connected. As far as PV system is concerned, it is the same, but then it depends on what scheme that you use. If you use NEM or SelCo, you need to connect to the AC distribution board. And if you use FIT scheme and you bypass everything, it is put here. And this is without energy storage. But lately, government allowed us to use energy storage as well. But all the while, we use GCPV system without energy storage. But lately, once the NEM launched a few years back, then government allowed us to use energy storage. So you can use your battery here. especially if you declare that you are going to self-consumption. So any surplus of energy that generated from your PV that is going to charge and store inside your energy storage, your battery, and then probably during night time, then you can use that energy. That's how it works. Now we look at the how it connects to your house, the system, the GCPV system using indirect connection. Why I focus indirect connection? Because as far as the policy, government policy is concerned, FIT already ended. So it's no longer FIT scheme. So the only available scheme that government offer is NEM or SelCo. So this is how it should be connected to your existing electrical distribution system. So you have incoming here. This is the cut out fuse, which is 63 ampere, and this is the meter, smart meter, supposed to be smart meters, then record how much energy you consume and how much energy you transfer to the grid. And this is your present AC distribution board. So your GCPV system here, you can connect direct to your present here. So any surplus of power will go to the grid and it will record by the export meter, and any power that you consume from the grid, then it will record by the import meter. So that's why you need to have a bi-directional energy meter here. Okay, let's look at what happened in 2005. In 2005, Malaysian government launched a program called Malaysian Building Integrated PV. So there's a group of people working under PTM. They started this project. So you may ask, what happened before 2005? Why it started with 2005? Before 2005, there are few installations. Example, in UIA in 1995, they installed the first system there, but that is the main focus is for research purposes. University they want to do some research on the PV system. They installed in 1095 UIA, and then UKM also they installed in 98. That is among the first GCPVs installed in Malaysia. And also TNB 2006. So they put this at the rest house in Port Dickson. But the main purpose is for research purposes. It's not meant for the commercialized use. But in 2005, government started to launch the first program for BIPV, or for the grid connected PV system. They call it a Malaysian Building Integrated PV, or MBIPV. So this is the starting point of grid connected PV system in Malaysia, commercialized, to make it to boost the activity of PV system. This is starting point. Before that, of course, there are a lot of off-grid system installed, but then it's not documented, so very difficult to manage the off-grid because a lot of agency, for example, the Kementerian Pendidikan, they have their own system. The KKLW also they have their own system. So there is no one unit center there. So starting from 2005, and government launched this MBIPV until the program ended in 2010. This is the starting point. And of course, during that time, this group of people managed to get funded from UNDP and Global Environmental Facility. And also government also put some funding inside there just to make the thing work, starting at the beginning of MBIPV. So the idea is to make the BIPV growth and also to reduce the cost. And during that time, nobody going to install it. I still remember because we involved starting in 2005 already on the GCPV system. Very expensive during that time. And this is among the installation, the first installation of grid connected PV system in Malaysia, in Shah Alam, in Semenyih, UniKL, UKM, and UIA. So UKM and UIA, of course, they are on academic, but they want to do some research about these things. So that's what they installed it. And at UniKL, this is a starting point where to train the local technical competency. This is the place, UniKL. Now, looking at this MBI PV project, as I mentioned, the idea is you want to reduce the cost. And initially, if you look at the cost in 2005, very, very expensive. You imagine 1 kilowatt, you need to spend 31,410 Malaysian ringgit during that time. So if you want to put 4 kilowatt PV on your rooftop, it costs you more than 100,000 Malaysian ringgit. Nobody going to install it during that time. So a lot of people wait and see, especially because this is a new technology. So in terms of reliability, has not been proven yet. So many people don't want to participate, and of course, to start the ball rolling, so government need to subsidize almost 70% at the earliest stage. Then those who are very concerned about the environmental, they want to contribute in something, then they start to use the system. They start to join this program and the IPV. And then this MBI PV team participated that the cost will be reduced. They predict based on blue, but what happened is that he found that the cost actually dropped much lower than they expected, as indicated in the red line here. You can imagine from 31,000, then in 2008 it dropped to 26,000. Still expensive. Still expensive. If you compare, you want to buy a small car, you imagine you want to put on your rooftop, spend you about 100,000. Why want to waste your money? A lot of people saying that instead of doing that, I might buy a new car. That's how people thinking during that time. So if you look at this one, the total of PV installed during that time, starting from 2005, we found that only 468 kilowatt, not much. And you see there's a slow increments of total PV installed from 2005 to 2006, because many people want to wait and see what happened. New technology, they are not still confident with the technology. Then later, after in 2007, and then they found that wow, this is quite okay, quite reliable, and in fact you save a lot of money, and the good word start to spread, and then a lot of people start to join the program. And during that time also, once a lot of people start to join the program, the cost will be reduced a little bit, as I showed just now. So you find that in 2008, we found that is the actual total installation is much higher than the expected or the target value. This is the example of a program done by MBI PV team. This is the place in Bangi. Now they call it MGTC. It's no longer Pusat Tenaga Malaysia or PTM. They rebrand the name of this building. They call it MGTC, and there are 94 kilowatt peaks installed on the rooftop here. So on the roof here consists of all PV, and then there's a transparent module here. So you can see very nice during middays, because the sunlight can pass through the modules here. And this is on the car park here. So the total is 94 kilowatt. And this is another site at the residential area. So the MBI PV also introduced another sub-program, we call it Suria 1000. You can find there are still articles about Suria 1000 in the internet. You can have a look and you can read the document about Suria 1000. So it started way back in 2005. Okay, and this is the first school that installed the GCPV system under Suria 1000 at Sekolah Menengah Kebahasaan Perempuan Sri Aman. Is a girls' school located in Petaling Jaya. So this is among the first that installed 4.4 kilowatt peak. And then what happened after 2010? After the MBI PV program completed, So government want to make this renewable energy sustainable throughout the year. So after the MBI PV completed in 2010, government introduced another scheme which is a very attractive. They call it FIT scheme. So FIT scheme started in 2011 and ended in 2016. So with FIT scheme, you are able to sell your electricity to the utility. That is called FIT scheme. So many people want to make money. So instead of they use the electricity, they sell the electricity. As I explain how it can be done, you can use the direct connection to the grid and you record how much energy that you generated. So FIT scheme, it is not focused on the PV, but also some other renewable energy. For example, the mini hydro and biomass, and you can find this information under SEDA portal. So SEDA was set up in 2011 under there's a parliamentary act just to manage the program FIT. So this is 2011. So SEDA also was established in 2011. So they look after this FIT program. So the total capacity of a PV installed in FIT scheme is about 387 megawatt. So if you compare for the last MBI PV program, it's not that not really attractive. But FIT scheme, you imagine you consume energy from utility, you just pay 37 cents Malaysia ringgit roughly per kilowatt hour per month, and you can sell 1 Malaysia ringgit plus plus. So that's depend on option. There are options given. For example, if you use the local product, then you might get higher tariff. But if you use all the foreign product, you import your inverter, import cable, import everything, import, probably you might get only 1 ringgit. But if you use local product, then you might get more than 1 ringgit. That is how FIT scheme was implemented in 2011 to 2018. Okay, this is a part of FIT. It boosts the market. Many people want to apply this FIT, but not everybody will get this chance, because it based on bidding. You have to submit, and you are lucky, then you get. If you're not lucky, you cannot get this quota. So the total allocation for residential is limited up to only 12 kilowatt. So that is a maximum that you can install FIT. Residential, but if you classify as a community, for example, it allows you to connect up to, or allow you to install up to 24 kilowatt. Community means mosque, church, the Bayaraya and so forth, the community places, then you can go up to 24. But if you declare you are industry, it allows you up to 1 megawatt. That's how it implement. So it's not easy. You need to bid, you need to submit, and then if you are lucky, then you can get it. It is not everybody will get this FIT. This is the example of pictures that the FIT under FIT scheme. The left-hand side here, this industry. You're also in industry here, and the right-hand side here in Bangsa. This is on the residential house, and this is also residential house. So those who manage to get this FIT scheme, they will enjoy up to 21 years. That is the agreement, 21 years. This is the pictures of the FIT scheme. This is how it looks like in a residential house, for example. And if you observe here, there's a 2 meter. This 1 meter here, there's supposed to be 1 meter here. So when we visited the place, this is under construction. So the export meter is not installed yet. Okay, the export meter is not installed yet. This is the import meter. So you're supposed to install the import meter here. So the import meter, the export meter will record how much energy that going to the grid. And this is another solar farm scale, which they also classify under FIT scheme. So they managed to secure this 5 megawatt system for FIT scheme. It's located in Terengganu, still 5 megawatt imaging here, it's quite big. And this is another solar farm, which is 1 megawatt. This is on the rooftop here. It's quite large area, and underneath there must be some economic activities. That's how SEDA define BIPV, Building Integrated Photovoltaic type of PV installation. So you need to have the economic activity under the PV roof here. If you have all the roof here consists of PV module, so you need to have the activities under here. So normally people use agriculture, so they use this under the module here. They use to the agriculture activities to plant some plant which is not required as strong sunlight. And as far as the mounting structure is concerned for Malaysia, when we connect the GCPV system, it consists of what we call, this is a retrofitted structure. So retrofitted structure is the structure where you install the module on the present rooftop. You have a rooftop, and then you need a special bracket, a special mounting structure to hold the module, which is called retrofitted. Building integrated here, you need to remove your existing tiles or whatever roof material here, and then you replace by PV modules. So why there's a difference between retrofitted and building integrated in FIT scheme? If you declare that you are in the BIPV or this building integrated, you will get extra bonus of the tariff. That's why people want to get as much as possible the tariff as high as possible. Then they remove all the tile here, for example, and then they put the PV modules to replace it. Instead of using this retrofitted, you might get a slightly lower tariff. And this is for the industry on the rooftop. So it consists of this one. This is also retrofitted industry. And this is a freestanding structure. And usually for solar farm, where you have freestanding, you can mount on the ground. Realizing this issue for the GCPV system, before 2005, Malaysian, we can find that a lot of PV installation failure. Before 2005, there are a lot of off-grid system installed at remote area. Nobody monitors, so a lot of failure. There is no feedback. Not one agency that monitoring the system. One of the reasons why the bad things happen to the off-grid PV system last time is lack of competency, lack of human power, lack of people knowledgeable in the technology. So people start to install it and leave it. So they don't train the local people how to handle the things. And most of the local people just receive the things and they thought that this is just a normal things. It's like they handle this genset, for example. So the technical knowledge is not passed over to them. So a lot of failure. We found that a lot of failure. And realizing this failure, so this government thinking about when we introduce the GCPV system, we are not going to repeat the same mistake again. We are not going, and we want to ensure this program is successful. Then government, especially through SEDA, we start to train local people. We start to train local people so that they are eligible, they are knowledgeable, and they are competent to handle this new technology. Especially grid connected for us during that time is very new technology. So SEDA has come up the initiative. They have come up with a 5 type of program to train the local people so that they are competent. They are eligible to handle the technology. So there are 5 courses here: grid connected PV system, grid connected for the chargeman, and grid connected for installer. So off-grid system and off-grid for system designer here. GCPV system here is the objective is to train the local people, especially the engineer stage. Engineer is not meant for the technician. This is meant for engineers. Grid connected PV system, we train the engineers after they graduated, come to the course to teach them how to design the system. This is number one. Number two is we train the present judgment environment. At present, judgment environment syllabus, they do not cover very detail on the GCPV. They only cover very detail on the AC. They can handle the AC system, no problem, because they are expert in this area. But they have little knowledge on the GCPV. So SEDA realized that we need judgment environment when we install the system, because they are dealing with the AC as well. So on top of their wiring and judgment environment certificate, they need to attend this course by SEDA to top up their knowledge on the PV system. And number three is for the school leavers. School leavers, especially after SPM, and they don't want to pursue their studies to the higher learning institution, for example, they are looking for the job. They don't want to, or maybe they don't have the opportunity to further their study. They can opt from this. This is for installation and maintenance course. They attend this course, and after that, then there's a company that take them for to be one of their employees or employers. And number four is the introduction to the grid-connected PV system. This is for the non-engineers, non-technical people, especially for the accountants, the decision makers. Many of them are not technical, so we don't discuss very detail on technical side, just to give them the broad idea what is a grid connector is all about, so that at least they can make decision, or at least they open up their mind. Oh, this is a grid connector system is all about. And number five is the off-grid system. This is of the off-grid system designer. This is for engineer level as well, same as grid connector, but we focus on the off-grid PV system design here. And these are programs certified by SEDA. So there's a selected institution selected by SEDA that can conduct this course. Okay? So after you pass through this course, and then you will get the certificate. That means I think it's quite demanding now, because people are looking at the qualified person that looking and designing and so forth. Okay? So for those of you who are really you have focus already, you want to pursue your career in PV system, so I strongly suggest to attend this one of these courses, especially on a grid connected, because you are in the engineer stage. So grid connected and also the off grid. Okay, these are the pictures when during a training session that we conducted at UITM, at GRC, UITM, one of the training center recognized by SEDA. So far we have conducted more than 300 people in the industry on designing the GCPV system. So we want to equip, we want to make sure many people know this technology, so that the system, the PV system, will be sustainable. The important thing here is sustainability issues. So without the local people expertise, without the local people knowledgeable on these issues, so this thing will be die out. So it's generally going forever. And also we collaborate with other ASEAN partners, the Vietnam, with the Thailand, Indonesia. We collaborate with them once a while. Sometimes we meet there and discuss the problem, and also they came over so in our place, and we do the discussion. So this is on the ASEAN country ASEAN level as well. So this is part of the training. During training, we teach them it's not only the theoretical value, but also we expose them with hands-on system, how to handle the equipment, how to do measuring and measurements, and so forth. This is an example of the picture of installation course, where we train them how to install on the roof. Of course, this roof is not that high, very, it's not that high. So that's why this trainer not wearing the proper PPE, because it's not that high. And the bottom one here is for the installer program. So sometimes it's a dedicated program. We want to ensure that we go to the site, to their site, and then we train them. Now, after this The program that I mentioned just now, the FIP, ended in 2005 something, yeah. Then government start another program, another scheme. So it does not stop until 2015. After FIT ended in 2015, then government introduced another scheme they call is NEM, Net Energy Metering. So this net energy metering started way back in 2016, and more or less it's not ended, but in 2019 when the new government take over our country, so they revised the policy of NEM. Before that, in NEM 1 2016 2019, if you have surplus energy that you sell to the grid, the tariff means the utility, you charge the utility with a not very attractive rate. If I remember during that time, the cost of electricity that you generate to the utility, you can sell only 21 cents, something, 21 cents per kilowatt hour. But then the tariff that you buy from the utility is 37 cents. So it's not that attractive. So meaning to say that it's some sort of the discourage people the sending electricity to the grid, because it charges you very lower rate compared to the one that you consume from the grid. But in 2019, when the new government take over, they changed the policy. They call it one-on-one offset basis. That sounds okay, because you sell the electricity, you can charge the utility with 37 cents per kilowatt hour, then you take also 37 cents. That's called one-on-one basis. So that's very effective for people. A lot of people start to use this one, NEMs. A lot of people start to apply for NEM2. In fact, before the program ended, in 2020, we found that 500 megawatt allocation for this NEM was fully subscribed. So not even reached at 2020, the program has already complete. So 500 megawatt, that's the total amount of power allocated for this NEM was fully subscribed. However, government introduced another scheme, they call it NEM3. Started this year, early this year. NEM3, 3.0 they call it. 3.0 started this year and it ended up in 2023. So they call it three, they classify into three categories. They call it NEM Rakyat, NEM Government, and NEM Nova. So NEM Rakyat is the one for public, so you can apply for this one, NEM Rakyat. So NEM Government is for the government institution. So any government agency that you have a building, government building, then you can apply for this one. Nova is the process that you can sell your electricity to your other client or consumer. So this is through they call it net offset visual aggregation, or in short, they call it Nova. So this information you can get detailed from Suruhanjaya Tenaga website or SEDA website. They have a very detailed explanation about NEM 3.0. But this NEM 3.0, the offset practice, the offset, you can offset if you have a surplus this month, and then you can bring over next month and so forth. It will offset unto 1 year. So after 1 year, you reset back to zero. And then the process of NEM3, it lasts up to 10 years already. So after 10 years, according to this planning, NEM3, after 10 years, so utility will not consider any more surplus power to the grid. So although you pass as your surplus power to the grid, most likely utility will not consider that power anymore. So most likely, I predict that, and during that time, you might use the energy storage. So you can use energy storage to store any surplus energy, and then you can utilize your energy from your energy storage during night time. So, and by the time, I believe that in 10 years time, the energy storage like lithium ion, the cost will be much lower as compared to now. So that makes it very attractive. Yeah. So same goes to the self-consumption. It started similar year with the NEM. The only difference between the NEM and self-consumption, the self-consumption allow you to use the energy that generated from the PV, but it is not allow you to export to the grid. That is called self-consumption. So when you apply for this scheme, you need to define. You need to select what type of scheme that you are applying, either SelCo or NEM. If you say that this is SelCo, then you have to find a method to ensure there is no power going to the grid. That is called self-consumption. However, if you say that you are going to apply for NEM, then of course they will consider your export power as well. And also in 2015, we found that Malaysians start to open up the large-scale solar farm project. The beginning, the large-scale solar farm project started, but this large-scale solar farm is not bound by NEM, SelCo, or FIT. So this is direct to the utility with the negotiation and also bidding process. So it's no longer managed by SEDA, but this is direct managed by Suruhanjaya Tenaga, ST. This is large-scale solar farm. It started that way, and the first phase of large-scale solar farm is conceived. They offer 30 megawatt and 50 megawatt. So 50 megawatt is the largest power. 50 megawatt is the largest PV array capacity that they allow in the first phase. And as of 2019, we found that this is the condition of Malaysia now. So as far as solar is concerned, if we include off-grid as well, so now it becomes almost 1 gigawatt installation, 1 gigawatt. Yeah? But I think if you are not including this off-grid, maybe slightly lower than 1 gigawatt. And the natural gas still the main dominant in our generation, electricity generation, and followed by coal. But later, probably once the solar farms, a lot of solar farm coming up, then it might be increased. The percentage will be increased. Now, after talking about GCPV system, let me introduce what actually GCPV system. This is the basic concept of GCPV system. You have a PV modules on the rooftop here, and then you have inverter. Of course, we need to have inverter. Why? Because PV modules only generate DC. There is no such thing as PV generate AC. So you generate DC, and then we need to invert the DC into appropriate voltage and frequency so that it can match with the grid here. So this is our grid line. So we transfer power from here to the grid. And then from this one, it go to your load here. And if any surplus power, let's say, for example, during daytime, so not much load connected to the system, then the power, the huge power here generated from the PV array here will go to the grid, and then your meter will record how much power that going to the grid. And during nighttime, of course, PV cannot generate power at all during nighttime. Then you can consume power from the grid here automatically. So you don't have to turn off and turn on the system. It will done automatically. That is how the grid connected PV system works. And this grid connected PV system only work with the presence of grid line. So without grid line, it will not work. That's called grid connected system. If there's some interruption on the utility line here because of whatever reason, maybe some maintenance, utility maintenance, they shut down the system for the maintenance purposes, then the inverter must shut down automatically. The inverter must sense the voltage, the presence of grid voltage here. Without grid voltage, the inverter will turn off. So we don't expect that if you turn on the interruption of grid here, you can get power from the PV module here, unless you have another type of scheme, which is including the energy storage. But without energy storage, we do expect that the inverter also turn off. Okay, this is the concept of grid-connected PV system, where you have load, you have PV array, you have inverter. The main concern is all your PV is generated from the PV array must pass through the inverter and must go to the grid first. Then you can take the power from the grid and go to your load. So grid must be present. As far as a PV technology is concerned, for Malaysia scenario, we normally use three types of technology, which is a monocrystalline, polycrystalline, and thin film. But under thin film, there are a few other technologies. Example, amorphous silicon, cadmium telluride, copper indium disalide. Yeah, and then hybrid modules. Last time there's a this hybrid modules, the pioneers of this HIT technology is from Sanyo, but the Panasonic bought over the Sanyo, and then I think last couple of months the plant in Kulim High Tech Kedah has already closed down, so they no longer produce this HIT module. So the one that we use now is these three type of technology. And as far as the inverter is concerned, there are a few types of inverters: string, central, micro, and also DC optimizer with inverter. I will tell about this technology. Yeah? And if you have energy storage, this is how the circuit topology looks like. And as far as PV module is concerned, also the latest technology, the modules it's not only on the single, or we call it a monofacial type, but now they try to improve the efficiency. If you notice that the efficiency of module here is not that high. Monocrystalline, the highest, the normal monocrystalline maybe about 70%, polycrystalline maybe 60%, thin film in fact was close to 10% only. So they try to push the efficiency of these modules. So although some manufacturers, they manage to get, especially on the monocrystalline, for example, some power, they manage to get more than 20, maybe up to 21, 22%. But most of the manufacturer of monocrystalline, they are still in 70%. So they try to push higher than that. So they come up with the passivated emitter rear cell to make improvement on the cell materials. They put another layer, and later I will show you what is put in short, and half cut cell, and also bifacial module. This is how they want to make improvement on the PV, because you notice that this efficiency of the module is quite low. This is another alternative solution, as I mentioned. After 10 years, so what will happen for Malaysian NEM? After 10 years, so this is one of the possible solutions where you can put the battery energy storage. Also, instead of you send surplus power to the grid or surplus energy to the grid, you can store inside the battery. So this is how the topology looks like, and this is the technology of battery. Under lithium ion, there are so many classifications because lithium ion is a generic name. It consists of many technology. And I found that this lithium iron phosphate battery is quite promising technology here. Many people start to use it, and of course, when many people start to use it, the power will be dropped. And this is, if you look at the connection on a low scheme, a low voltage connection, and this is the FIT scheme just now. I just show you this one. This is based on the NEM or SelCo. And this is how we connect for the medium voltage system, especially on the factory. Factory where the incoming is 11 kV, we don't connect to the 11 kV, except for the FIT scheme. Yes, we need to connect direct to 11 kV. But for NEM and SelCo scheme, we need to connect to the DB, which is very close to the load. For example, you have a DB here, then you have a GCPV system here, and then connect to a DB. The purpose of this NEM and SelCo is to provide power to the load first. Any surplus of power then can go to the grid. Yeah. So that's the purpose. That is the main purpose of NEM. So NEM and SelCo is not meant to make money. We just want to reduce the electricity bill. energy consumption from the utility. And this is example where we put the data logger here. We put a power analyzer, connect to the GCPV system at this point, and also we connect at this point. And this is what happened during weekend on Saturday and Sunday. We found that if you look here, this is positive value. What does it mean? There's a positive, they mean the power coming out from the GCPV system, and we tag here, there's a negative power. That means because the load during weekend, a lot of load shut down, not many activities here. So most of the power is generated from here, go to the grid. That's recorded by negative here. So during weekdays, so what happened is that we see here, there's a positive and negative. So early in the morning, probably there's not many load connected or not turned on yet. So we found that there's a negative here part here, and then the rest will be positive. So positive means here, especially this part, that means there is not enough power generated by the GCPV system. So the power will be come from the utility. That's why you can see the positive part here. This is how the system works. So it will be done automatically. So you have to turn off, turn on the system. This is for the solar farm, the big scale. You might wonder, how does the big scale solar farm connected 50 megawatt or 30 megawatt, how it will connected? For example, if you notice that on the highway to Kuantan, there's a one solar farm there, 50 megawatt owned by UITM. And 50 megawatt, you need to connect to the 275 kV. So you need to have a 2 step-up transformer here. So this is one step-up transformer. If you connect, for example, just 5 megawatt or the whole system here, then you need to have only one step-up transformer. But for the bigger system, 50 megawatt, you need to connect to the high voltage. This is 275 kV. So at this, for example, this is more or less about 5 megawatt. So if you look here, there are plenty of inverter here. Maybe more than 100 inverters connected to the system here. And these inverters are connected in parallel. So they process the DC power here, and then they sum all the AC power here and go to the inverter and go to the utilities. This is how the solar farm works. Yeah. This is distributed. As far as GCPV system, there are two types of system. We call it a distributed system, where you install on the small system. For example, this car park here. So this we put on the rooftop here, and then this on the roof here. Maybe about 2 kilowatt or 3 kilowatt small system. And also this is also distributed system. This is on the house, the school, and this is one of the factory, and this is also on the house. Okay, so this is all distributed system, meaning small scattered system. So instead of solar farm, this is a centralized. Centralized means solar farm. So you have a big scale of system and then connect to one point. This is called centralized system. This is 8 megawatt solar farm in Melaka, and this is a 50 megawatt solar farm at Sepang, Selangor. This is a 10 megawatt solar farm at Gebeng, Pahang, and this is a 50 megawatt solar farm at Gambang. This is owned by UITM. This during that time is still under construction. Now it's already operating. It's operation. Now we look at the schematic diagram. What is all about the grid connected PV system? So according to this Malaysian standard, we have Malaysian standard MS 1837. This is an indigenous Malaysian standard. So it is not IEC, but this is typically Malaysian standard 1837 2018. This is a second revision. The first MS 1837 is 2005. The first revision is 2010. This is a second revision 2018. So inside the standard, the standard, this is the schematic, generic schematic for single MPPT inverter. This is how it looks like. So every designer, when they produce the schematic, they have to follow the symbol, and also all the components must be there if they follow the Malaysian standard. So you might wonder, what is this single MPPT means? This is normally, if you have only one side of your house, you want to install it, and it is okay to have one MPPT inverter. But in case you have multiple orientation, you have two sides, one is facing north, another one is facing south, for example, then it is advisable to use this multiple MPPT. So you need to have a multiple MPPT inverter. So this side facing connect to this side, and another MPPT connect to another side, so that you can make the system optimum. And this is for three-phase. In case you have a three-phase supply, then this is how it looks like. Okay? So this is also extract from MS1837, three-phase system. And then if you have this multiple MPPT, also you can use for three-phase system. And in case you have multiple orientation, for example, some house you have multiple, so many orientation. It's not only two orientation. Yes, there is house you have only two orientation, but bungalow house sometimes you have multiple orientation like this. So it is better for you to use this another inverter because it's micro-inverter. So Malaysian standard recommend this is how we connect the micro-inverter. You put the inverter under the module. Every module you have inverter. This is called small inverter. This is a handphone size of inverter you can put under the module here. So this inverter can handle small power, just one module. They can handle one module. So this inverter will invert DC power that produced by the PV module to the AC. And you can connect this inverter in parallel. This is how you can get connected. Yeah? So you can manage this thing. The beauty of this one is in case the building caught fire, for example, caught fire. So what happens if you turn off this easy AC switch here? So there is no power supply along this line. But for the one that I mentioned before this, for example, the system on this one, multiple MPPT inverter, if the building caught fire, you turn off this one, you turn off AC switch, you turn off all this one, and the voltage here will be very, very high. So it's quite dangerous. So you cannot touch this live. Otherwise, imagine this voltage is easily can go up to 800 or 900. It depends on how you design the number of modules in string here. So it's very, very dangerous. So in terms of safety, this one is better because once you turn off the AC here, so no power line, no power in this AC cable here, and then only at the terminal output of this module, which is very low, so it's still safe. Another option is that you can use this DC optimizer instead of micro-inverter. You can put DC optimizer here under the module, and then you can connect to this inverter. The purpose of DC optimizer is to optimize the power of each module. So you can put this module facing north, you can put this one facing south, doesn't matter, because each individual module will be optimized by this optimizer. The power of each module will be optimized by this optimizer. So there is no mismatch issue in this case. That's how beauty is the DC optimizer and also the microcontroller. So as far as Malaysia is concerned, there are two standards that we developed. This is indigenous standard, not IEC, but this is called in Malaysian standard MS1837 2018. This is the second revision. We keep updating as the technology changes. We need to upgrade and update this information under this Malaysian standard MS1837. And last year, we managed to publish this MS2692. This is 2020, last year. So we published this is for testing and commissioning. After you install the GCPV system, we need to test, we need to commission the system. So this standard is quite detailed. There's a checklist that what are the things that you need to comply. Yeah, what are the things you need to, there's a checklist, you need to tick whatever that you have done, just to ensure that everything in place, everything in order. And beside that, we also refer to the IEC standard, IEC 61727. This is for interfacing, yeah, utility interface. And also IEC 61724. This is for measurement data exchange analysis. Some of the formula is very complicated inside here, 61724. But 61724 is not meant for grid connected, but it's covered for both off grid as well. So you can use this 61724 to do analysis for off-grid and also the grid connected PV system. So you need to adjust the formula accordingly. This is the GCPV system in Malaysia just now. And this is the UITM gambar 61 megawatt. For those of you who travel to the East Coast, you can find that this on the right hand side. 61 megawatt large scale solar farm is running. Since, and also 31 megawatt also owned by UiTM in Pasir Gudang, 31 megawatt in 2020. This solar farm scale, and also we have this floating solar PV. So there's a one. It's not one actually. There are a few sites with a floating solar PV. They put on the reservoir, but this 100 kilowatt peak Sungai Labu floating solar is for testing purposes, and also TMB they also install few sites using the floating solar, just for probably they want to look what happened to the system, because floating solar you need this space. Not every place that you have this water, the reservoir, on this specific area. Now, as far as SEDA is concerned, if you look at the SEDA portal, they give the SEDA as the completed a project called National Photovoltaic Monitoring System, or in short, National PV Monitoring System. So if you look at this portal, SEDA portal, it is online data, keep on updating every 5 minutes. So you can see the live data of about 120 sites all over the places, from Perlis up to Sabah here. So there are 120 sites online monitored by SEDA. So this is based on the FIT scheme project. So it's excluded the solar farm only up to 1 megawatt. This is under the FIT SEDA. So for those of you who want to study, or maybe you need data, for example, if you make research or whatever, you need a data, solar irradiance, the ground data, probably you can buy this data, because every site here, SEDA provide a continuous data. So they have a logger there, and then there's a data there, and of course you need to pay a small fees to SEDA, and you can get all the data which is located here. So you can see. So instead of you use the satellite data, for example, you can use this ground-based data. So ground-based data is more accurate than the satellite data. Yeah, ground-based, because all the sensors here, you can the sensor they have is the horizontal sensor, the module temperature, and also we know the performance of PV system that installed at this particular site. This is online, yeah? So you can see using this portal, the SEDA portal. And this is example of from the portal just now. I just snapped the picture. This is how it looks like. So they monitor this type of system. This is the sensor that they install. They have a sensor here. So the sensor consists of temperature, the ambient temperature, and there's a wire connected to the back of the module to measure the module temperature, and also the sensors that to measure solar irradiance. This is the horizontal plane solar irradiance, and also wind speed. Measure also wind speed. So if you want to make a study on wind speed, that particular dotted green, and then you can find this data. So as far as the PV technology is concerned, we found that this is the conventional type of PV module where we have only one phase. This is a conventional type of PV module. So we have three types of technology. As I mentioned just now, we have poly, mono, and thin film. Poly is widely used compared to, mono is widely used compared to poly because of highest efficiency. And polycrystalline is better than thin film because polycrystalline has a higher efficiency compared to thin film. But then if you talking about the sensitivity with the temperature, the thin film is less sensitive with the temperature. So as the temperature is getting hotter and hotter for the PV module, there's a small drop of power in the thin film. But the polycrystalline, you can find that there's a significant power drop. Yeah. So polycrystalline is a higher power drop. So this is a monofacial module. This is conventional. So we use this type of module long time already. But then the manufacturer try to improve the efficiency of the products, and they put another layer here. They call it PES. They put another to reflect back whatever sunlight that pass through the upper layer here, so that it can reflect back, so they can utilize those light, the sunlight. So to increase, the idea is to increase the efficiency. They call it PERT module. So you find that most of the PV module now is PERT module. And then they also produce another type of module, new module, they call it bifacial. So instead of just one active area, they also develop this at the back here, also another active area. So the sunlight bounce from the back also can generate additional power to the module. That's how they call it bifacial module. So you find that this type of module, you have a glass in front there. On the surface here is from glass, and at the back also they have a glass. So you have glass to glass. It's no longer glass to the insulator at the back there, or bed sheet they call it. Yeah, but now you have a glass and glass, and this according to manufacturer they guarantee up to 30 years. So the standard monofacial module only they guarantee up to 20 years, where the power degrade about 20%. But this one they guarantee because you have glass to glass, it can last for 30 years. This one, yeah, 30 years. This is the testing that they've done. If they have this bifacial module, if you have a white paint, then you have a very good reflective at the bottom, at the back. Then you might have an additional 19% power increase compared to the only one single-sided. And these are type of the material that they suggest, and they have tested this one. So imagine if you use this bifacial module on the floating solar, you can increase only 5%. So 90% is better, but you need to paint. You need to paint with a white paint so that you have a good reflective surface. And this is another technology that you use. They call it half-cut cell. Original cell here they cut into half here, and the half here they put it on the upper part here, and then the half they put the bottom here. So what happened is that in case any soiling that appear at the bottom part here, it won't reduce the total power of the whole modules. That's the idea. So in that case, what you can say that it can increase the power of the system. This is how the system looks like when we do the monitoring. We have a sensor here. This is a solar irradiance sensor, and this is the temperature that we put the sensors under the module. We put the sensors under the module to monitor the temperature of the PV module. So these two parameters is very important when we monitor the system: solar irradiance and module temperature. And lately, I take example, Huawei, they come up with a smart type of system where they have a smart logger, and they can connect to you can connect to the so many inverter and the smart logger, and you can manage the smart logger. You can instruct through the smart logger for the inverter to do the IV curve tracing. This is very important for those of you familiar with the IV curve. So we can instruct the smart logger, and through the smart logger to instruct the inverter to perform IV curve every string. So traditionally, we take a very specific equipment to do the IV curve manually, but now you just can send a signal to the smart logger to perform IV curve. This is a very fantastic, this is a very excellent technology where it can help you a lot in order to diagnose the system. This is how it looks like, where you compare the IV curve. You can detect anything happen to the string, so without detach the system. So that will done automatically by the inverters. And this is the outdoor installation in Malaysia. So found that Malaysia as throughout the year, we are in hot climates throughout the year, except in maybe in December we slightly during the monsoon season. But the inverter here is very sensitive with the temperature. Very sensitive with temperature. So in installation temperature, when we install the inverter, we have to ensure that it's under the shade. Although the inverter is stated that this is IP65 where you can install outdoor, but then outdoor installation, it doesn't guarantee that you can the temperature will not affect the performance. So we normally install under the shade of inverters. And then because if you look here, every inverter they have a characteristic This is a serious issue in Malaysia because very high humidity with a very hot climate. So we need to maintain the temperature so that the system will work accordingly. And also we need to ensure that everything will be okay. So as a conclusion, what I can conclude from my talk is that this GCPV system actually have created a lot of job opportunity. Beginning from 2005, I think thousands of people already involved with this, especially on the design and also installation. You can imagine 50 megawatt. So how many people that you require? Design, installation, testing, commissioning, and also monitoring continuously. There's a lot of opportunity here, but we need to equip ourselves with the technical knowledge before we jump into this area. You need to equip yourself. And so far, government have a strong support. This program, especially on PV, government look at it is a very good, it's a reliable type of technology. So imagine starting from NBI PV, so followed by NEM, starting from NBI PV and then followed by FIT and then followed by NEM and SelCo and then now the large scale solar farm. So it looks like government have the proper schedule in place. So I believe that after 10 years, so there's another scheme coming out with the government. Right? Until now, let's wait and see what happens in 10 years' time. So the technology is sustainable because they have put everything in order. So we in the process keep on training the local people so that they must equip with the technical expertise and technical knowledge, so that any new things can be handled by the local people. It's not 100% rely on the foreign. Of course, certain technology we need to rely on the foreign technology, but certain things, especially on the handling, monitoring, to make the system sustainable, so we need to equip with the local people. And PV is long lasting. It's long lasting, very long lasting. As for the PV modules, many people ask about what happened after 25 years because manufacturer they guarantee 25 years. 25 years is only the performance guarantee. That doesn't mean after 25 years you need to replace, you need to throw away the module. No, you just put there. Only the power drop 20%. Okay, so it's lasts long. And in fact, the bifacial just now there's a two glass, double-sided glass they call it. It guarantee lasts for 30 years. 30 years means the power drop 20%. And of course, PV is not maintenance. PV is not maintenance, but it is a less maintenance. It is not maintenance, but of course, it is a less maintenance. You don't have to replace. You don't have to replace any part in the PV system, like the ordinary genset, for example. You need to replace the oil filter, you need to replace the oil, engine, and so forth. But PV, there is no replacement part. There is no moving part. So less maintenance. And the OPEX, operating expenditure, is very low. OPEX. What you need to do is just clean the module, that's it. Clean the module, and of course you need to make sure that there's no shading caused by any nearby vegetation and so forth. And PV is, of course, I agree, is high capex, high capital expenditure, but it have a shorter payback period. Now, people also ask, what is the cost for GCPV system now? You imagine in 2005, it cost about 31,000 per kilowatt. Now, it's already about 3 ringgit per watt. So about 3,000 per kilowatt now. 3,000, 3 to 4 Malaysia ringgit per kilowatt. So let's say, for example, you want to install on your rooftop now using NEM. You want to install 4 kilowatt. So probably just spend about 12,000, 12 to 13,000 now. Imagine last time it cost you about more than 100,000. No, the cost is dropping. Okay? So payback period is about 4 to 5 years. That's how they calculate. According to industry, they estimate that is about 4 to 5 years. High capex. With that, thank you very much. It's almost 1 hour, a little bit. So thank you very much.
interesting talk. On behalf of the organizing committee, I would like to thank Honorary Prof. Ahmad Maliki Omar for the very informative talk. I believe all of us understand the main points from the broadcast now. Now, I will proceed with the Q&A session. Let us start our Q&A by inviting Dr. Farid to ask questions to Prof. Maliki.
Okay, Prof, very insightful and informative presentations. I'm very interested on when you mentioned about the export and import meter. Can you elaborate a little bit how we distinguish between the import and export? I think it's about some about the current flow or what is it in terms of technical that distinguish between export and import meter?
Okay, thank you. Regarding the question about export and import meter, actually is regarding the power flow. They detect the power flow, the current, and also the voltage. But the smart meter that's installed by TNB, they have already incorporated that features. So if you look at your present smart meters at home, I believe that in Klang Valley, Shah Alam, they have already installed for free. They install. My house is already they changed to the smart meter because nowadays there is no meter readers reading the meters. They just log at the substation so they can access your data. So they use the meters. And if you have a smart meters, there's a coding. If I'm not mistaken, there's a 051 and 052. You press that coding, and then they will show you what is the export, what is the import. So the concept is based on power. So power flow, that power that going into the grid will pass through the export meter, and power that coming from the grid will pass over to the import meter. And at the end of every month, the meter reader will offset whatever total energy that you consume. And if you have surplus, for example, then you bring forward to the next month. But the process, according to the government, the latest NEM3, the process the process of carrying over the surplus power will be only 1 year. Last time is 2 years. Now it's already 1 year. So after 1 year, then you need to finish your surplus power then. Otherwise, it's going to reset back to zero. Then start again in January next year, for example. Okay.
Okay, so next I will read the question from the audience. And the question is from Facebook Live. The question is for GCPV with energy storage. How does connection of the machine do we need OGPV safety environment certificate for the installation?
This policy is depend on the Suruhanjaya Tenaga policy. This one. So you can ask this question to the Suruhanjaya Tenaga or the SEDA because they're the one, the regulatory body. So I cannot answer on behalf of them. This one because this is regarding the policy. Whether you need to have the qualified person to do the wiring, or you need to have this certified wiring. This you can ask this question to the regulatory body. Especially, I think for the NEM scheme, you can ask SEDA. They can answer it. And for the other scheme, for example, the solar farm, then you can ask ST. But NEM and SelCo, you can ask direct SEDA. They will answer it. Yeah? So I can answer on behalf of them.
Okay, for the next question is from YouTube. Is there any advantage of the floating solar as compared to the rooftop solar?
Okay, thank you. And we don't have actual data to make a concrete conclusion. Is it the floating solar is better than the normal solar installation or rooftop solar? But according to the concept of theory, if you can bring down the temperature of the module, then you can increase the power. That's the concept. So if you can bring down the temperature of a PV module, then you can increase the power that generated by the PV module. So if you compare rooftop with the floating solar, so we do expect that floating solar, the back temperature, the temperature at the back will be much lower than rooftop. But we do not know the effect of humidity, because you put on solar, you put on the floating solar, does humidity will affect the lifetime of your PV modules, the humidity, as compared to rooftop solar. And rooftop solar also, when we install, we have a certain gap just to ensure that it doesn't increase the temperature of the PV modules. So there's a gap that we allow the free air ventilation under the module. So we do not cover, when we install the rooftop solar, we don't cover all sides. So we have to make the module or keep the module slightly lower temperature. Yeah. So I cannot make I don't have the actual data of the floating solar, but theoretically it depends on the materials and also depend on the technology that is.
Okay, for the next question, first, may I know your personal view in terms of performance about bifacial PV technology implement in Malaysia in the future? Is it suitable for our country?
Okay, thank you, Shafika. Long time no see you. Huh? Okay, so regarding the bifacial, the most of the manufacturer, they are moving toward producing the bifacial module. But if you want to get advantage of the bifacial module, you have to look at where you are going to install the PV modules. If you want to put your PV modules on the rooftop, for example, so I not see the benefit of it because you cover the back. But if you are talking about you want to put on a freestanding, especially on the concrete rooftop, and then you want to paint your concrete rooftop with a white paint, for example, then I believe that you can get advantage of it. Okay, so yeah, many manufacturers, they are moving toward the bifacial. Yeah, of course, and they claim that that is not much different in terms of cost when they compare with monofacial. Of course, bifacial, you need to have a glass to glass. You need to glass, and it lasts longer. As I said, 30 years. They guarantee 30 years. So much longer time for you to use it as compared to mono. Mono normally 20 years, but 20 years, sorry, 25 years with a 20% power drop. That is a standard for the mono or the monofacial type of model.
Okay, for the next question, from YouTube, how you can solve issue due to power factor problem in solar system?
I think we have another session to talk about power factor because it's a long explanation, the theory, the concept, and how you can improve the power factor. Yes, I agree because basically, since you asked about the power factor problem, so normally I conduct 1-2 hours lecture about how to solve the power problem. There's a few solutions that you can do that, but basically, what I can say that if the PV module, a GCPV system by default, you just generate active power by default. You just generate active power. So once you generate active power, that particular plant, they have also reactive power consumption. So once you generate more active power, so the ratio of active power, the reactive power that you consume from the grid will be unbalanced. So what happens is that your power factor drop. That's what happened. So how to improve it? There are a few alternative, few solutions you can solve it. So one of the solution, because of time consuming, one of the solution is you can generate reactive power from the inverter itself, just to balance between the ratio of active and reactive power that you consume from the grid. That is another one of the solution.
Okay, from YouTube Live also, Assalamualaikum Prof. What is your opinion on the future of the rooftop solar application? Is it will become more price attractive?
Yeah, I think rooftop is a very good potential because everybody got a rooftop in the town area or in the village, kampong area, whatever. So everybody can apply for rooftop. But talking about the, let's say, for example, for a floating solar, not everybody can install floating solar, and also the freestanding structure, not everybody have the land to install it. So everybody can install it. In fact, you stay in Shahalam also, you have a terrace house. Instead of nothing to do on your rooftop, why don't you put a PV module there, generate some electricity? Then you can reduce the electricity bill, the extension. And I believe that 10 years time, of course, many people say that they worry because after 10 years of NEM3 that government have launched, government will not consider the surplus of energy. So for me, it's okay. During that time, we change the strategy. Then we use energy storage. And energy storage, you cannot imagine like the battery that very heavy. But during that time, lithium ion is very light. You can mount on the wall your battery. There's a lot of quotation on lithium ion technology. And the price is dropping down now. So during that time, I believe in 10 years time, this lithium ion, you can simply every house, you put a battery on the wall, just mount on the wall. So it's okay if utility don't want to accept your surplus energy, then you can install it. You can use it. You can still reduce the electricity that you consume from the grid. And I still believe that the technology is still required. And because the electricity keep on increasing. Now, probably it's not that expensive, but later there's a lot of increasing and a lot of people, consume a lot of power. Yeah. So you need to generate this extra power.
Okay, for the next question, are there any incentives to use local product for solar installation? For example, locally product produce inverter versus foreign goods.
This is also regarding the policy, government policy. Government policy. You can ask the Matret about this thing. But as far as I know, uh, only applicable for FIT. Yes, FIT, you have an incentive where you have a higher tariff if you use a local product. But for the NEM, I'm not really sure. But you can ask Matret, so they know better whether you have incentive, maybe tax incentive or whatever incentive because of RE. Okay. The detail, I think you can look from the Matret and also SEDA because this is regarding policy. You can ask me about the technical things.
Okay,
That,
for the next question, cost. How
yeah,
formula or
okay.
calculated of the circuit voltage set for percent difference of the output?
Yes, there is a formula to calculate string open circuit voltage test. And you can have a look detail in the MS1 and MS2692 that we have published. That's very detailed. Or if you don't want to buy, you can look at this SEDA portal under technical guideline. They call it technical guideline. It's a free under in PDF format. So you can download the data. There's a formula. So basically, what I can say formula is you need to know what is the module temperature during that time, and then we can predict. It's not predict, actually. We can expect what is the open circuit voltage during that time, and then you need to compare with the actual voltage, and then you divide the expected voltage, and then multiply by 100. So according to SEDA, if the deviation is outside the plus or minus 5%, then the system fail. So you need to repeat again. That's how we do this open circuit test. String open circuit test. This is under test and commissioning. It is required for all installation. You need to do this string open circuit test. Okay.
Okay, alright. I think that is the last question. There are a lot of questions from the audience, which means the topic is really interesting. I would like to thank Prof. Ahmad Maliki Omar for answering the questions from the participants. Before the program ends, we would like we would like to inform that we have provided a link to answer the quiz in the chat box. The quiz is based on the Prof. Maliki podcast now. For the quiz, we will announce the winner in the I3P UITM student branch website, and e-certificate will be given to all participants. With that, we have come to the end of the program. I hope all of you could support all of our upcoming events. Please follow the I3P Plus Malaysia and I3P UITM student branch Facebook, Instagram, and also YouTube channel. With that, thank you so much everyone. Stay safe. Assalamualaikum.